The third form of loop is when you have to repeat a set of instructions until a condition is true. This is the schema. So, let's see, how do we use this schema? The objective: read a number and calculate its factorial number. Semantic analysis. What is read? In the computer programming world, what is a number? Yes, I know, you know that, but write it. What does factorial means? Okay? So read is receive data using the keyboard from the user. Okay? Number is a value. Factorial, this is the key of this exercise. Factorial is a successive multiplication of the numbers between 1 and specific number. Example, the factorial of 4 is the result to multiply 1 by 2 by 3, 1 by 2 by 3 by 4. And that means 24. But to remember these rules, the factorial of 0 is 1. And there is no definition of the factorial for negative numbers. Okay? You understand the semantic analysis, you really understand the objective. Let's see the IPO analysis: input, process, output. Okay? First step, read a number. So you need to read a number. N is the name of the variable that will storage the number. Okay? Then calculate its factorial number. Step number 2. You need a variable factor equal to 1. And then you need a variable out equal to 1 too. Okay? Step number 3. Repeat. Right here, repeat. Factor is equal to factor I out. And then out is equal to out plus 1. And repeat this until out greater than n. And this is the loop. Okay? What is the output? Okay, the output is right factor. Let's see equal test. You see, it is very easy. Programming is really easy. RAM memory and display, right? RAM memory. You need to write the variables here, n, facto, and outs. Okay? Step number 1, read n. Then suppose you read 4. So the number 4 will be here in the variable n. Then step number 2, factor is equal to 1. So factor is equal to 1. Then out is equal to 1. Now step number 3, repeat. Factor is equal to factor by outs. That means 1 by 1 is 1. Okay. Outs is equal to outs plus 1. Now, until outs greater than n. 2 greater than 4, false. So you go into the repeat instruction. Factor is equal to factor by outs. Factor by outs is equal to outs plus 1. So outs is 3. Until outs greater than n, 3 is greater than 4, that is false. So you go to the repeat instruction. Factor is equal to factor by outs. 2 by 3 is 6. Outs is equal to outs plus 1. Now, until outs is greater than n. That is false. So you go to the repeat instruction. Factor is equal to factor by outs. 6 by 4 is 24. And outs is equal to outs plus 1. So until outs is greater than n, 5 is greater than n, that is true. 5 is greater than 4. So the instruction is write factor. Factor stores 24. You receive a number, you write the factorial of this number. You reach the objective? Yes, of course, you reach the objective. And now let's see the second statement. The objective. Read two numbers and multiply all the numbers between them. Semantic analysis. Read. Remember what is read? Let's write again. Numbers, two values, of course. Multiply all the numbers between them. With an example. With an example, we are going to define that. So, read, you now is receive data from keyboard. Two numbers is two values. Okay, and multiply all the numbers between them means, let's see an example. If you read 2 and 5, you have to multiply 2 by 3 by 4 by 5. And that means 120. Okay? Do you understand this semantic analysis? If you say yes, it is very clear, that means you really understand the objective. Let's see the analysis using a repeat until loop. Input, process, output, right? Input. Read two numbers. So the first step is read and one. This is a good name. And two. Num and n2 means read a number and stores in n1 and read another number and stores in n2. Now the process. Second step. Result is equal to 1. Okay? Step 3. Aus is equal to n1. Step number 4. Repeat result is equal to result by aus, and then aus is equal to aus plus 1 until aus is greater than n2. Okay? Now the output, number 5, write result. Now let's see the equal test. Run memory and then display. Okay. So variables n1, n2, result, and aus. Step number 1. Read n1 and 2. Suppose the values are 2 and 4. That means 2 is going to n1 variable, 4 is going to n2 variable. Result is equal to 1, out is equal to n1. That means 2. Repeat, result is equal to result by aus. So 1 by 2 is 2. Aux is equal to aux plus 1. That means 3. Until aux greater than n2. 3 is greater than 4. That is false. So you go to the repeat instruction. Result is equal to result by aux. 2 by 3 is 6. Aux is equal to aux plus 1. Until aus is greater than n2. 4 is greater than 4, that is false. So you go to a repeat instruction. Result is equal to result by aus. 6 by 4 is 24. Aus is equal to aus plus 1. Until aus is greater than n2. 5 is greater than 4, that is true. So write result. Result is 24. And you see, you receive 2 and 4. You multiply the numbers 2, 3, and 4. 2 by 3 is 6. 6 by 4 is 24. This is the number here. So did you reach the objective? Yes, of course you reached the objective.